I'm Algebra Annie, and I am here to help you be successful in your algebra class. Mistakes are proof that you are trying. Unknown. Our learning target today is I can graph and solve linear inequalities in two variables.
So now we are solving linear inequalities. And we've got two problems that we're going to start with. I'm going to draw a line right down the middle so I can separate them. And so that we're not confused looking at this problem while we're doing this one, I'm going to go ahead and cover it up. So we're only going to deal with this problem. And it wants to know, so tell whether the ordered pair that we are given, if it is really a solution. So this is actually how you would check your work. So we're basically just checking. So let's go ahead and check. And let's see if that point is actually an answer or not. So this is an xy coordinate point. And we are given the equation y is less than x minus 1. xy, my y is 3, is less than my x of 7. And the rule was to subtract 1. Let's go ahead and prove it. We're solving it. So the left needs to be solved down to a number. The right needs to be solved down to a number. Well, the left was already 3, so it's still 3. The inequality symbol is less than. What is 7 minus 1? 7 minus 1 is 6. So now that we've come down to a statement, we need to tell whether or not this statement is true. Is 3 less than 6? This statement is true. 3 is smaller than 6. If the statement is true, then this is in fact an answer. So you are then going to say that the coordinate point 7, 3 is a solution. So the whole point of tell whether the ordered pair is a solution to the inequality or not is you asking yourself, does the xy coordinate point actually make the statement true? So let's go ahead and look at the second point. So here's our second problem. They want to know if the coordinate point 4 or 5 makes this statement true. So we are checking. Check to see if that answer is a correct answer or not. So y is greater than 3x plus 2. This is an xy coordinate point. I need my y, which is 5, is greater than 3 times the x of 4, and I'm supposed to add 2. You are checking. So you got to solve the left all the way down until it's a number, solve the right all the way down until it's a number, and then check to see if the statement is true or not. The left is already 5, so it's 5 is greater than 3 times 4 is 12, so we have 12 plus 2. 5 is greater than 12 plus 2 is 14. Is 5 greater than 14? 5 is not greater than 14, so this is not true. If the statement's not true, then you know that the coordinate point is not a solution. So now we're being asked to graph the solution to a linear inequality. We know how to graph solutions to linear equations. Now we're moving on to inequalities. And if you recall, the inequalities have these symbols. These are the inequality symbols. So step number 1, we need to take a look at our equation and we need to solve the inequality for y. Much like when solving for linear equations, the equation needs to be in a y equals mx plus b form. But since we're talking about inequalities, you're going to have y and then some inequality symbol, mx plus b. It needs to be a y equation so we know how to graph it. So step number 1 is to solve the equation for y. So the equation we started with actually already has y by itself. So far step number 1 is done. So now we're going to move on to step number 2. Step number 2, you need to graph it pretending that it is actually a y equals equation. Now what do I mean by that? If I had to graph this, my y-intercept is 4, and I need to find my slope. The slope is the number stuck to x. My slope is 3, but remembering slope needs to be a fraction. So slope of a fraction is 3 over 1. So step number 2 was to find all the necessary information so that I could graph it. So I needed to graph this. My y-intercept is 4. My slope is up 3 over 1. Up 3 over 1. Now do not connect yet. That is the difference between linear equations and linear inequalities. So step number 3, since we're dealing with inequalities, we need to connect these differently. So step number 3 is to connect the inequality. Now you need to be careful. We have inequality symbols that do not have an equal sign, and we have inequality symbols that do have an equal sign. If it does have an equal sign, it means that every single number on the line is an answer. So we would do a solid line because every single number on the line is an answer. Well, if there is not an equal sign, that means we can get ever so close to the line, but that the exact number on the line is not an answer. And how we do that is that we draw it as a dotted line. Remember, this was your shaded in, so there's your shaded in, and this was your open, so there's kind of our open. So that means that we need to connect this line using, it does not have an equal sign. So that means for this particular problem, we are connecting it with a dotted line. So I'm going to take my ruler, and we are supposed to be connecting our line, making sure that it is dotted or dashed. So there is my dashed line because the symbol in our problem was a less than symbol. There was no equal sign in it, so it's going to be dashed. Now, when you recall, when we had originally graphed inequalities way back in chapter 3, there was shading involved. There's going to be shading involved in this too. So step number 4 is figuring out how to shade. Now, if it is a less than symbol, we would shade below the line. If it was a greater than symbol, we would shade above the line. So step number 4 is you trying to figure out how to shade in relation to your line. So now I need you to think about slope dude. Slope dude always starts the furthest on the left and goes from left to right. So slope dude is going to go this way on our mountain. Looking at our symbol, our inequality symbol, we had the less than. So where is our less than right here? He is right here, which means I'm supposed to shade below. So as slope dude is going on the mountain, where is below him? Below him would always be this direction, below his feet. So no matter where slope dude is on this mountain, because slope dude would start here and he would go this way on the mountain, below his feet's always this way. So any coordinate point over here would make this statement true. So everything over here in the shading is an accurate solution for this inequality. Let's go ahead and do another one. So step number 1 is to make sure you solve for y. So here's my equation. And I do not know how to graph it yet because it's not solved for y. I need to solve for y. So I'm going to subtract 3x from each side. So I have 2y is greater than or equal to, that was a negative 3x, and that was a positive 6. I still need to get y by itself. So I'm going to divide both sides by 2. Now wait, you remember when we were dealing with inequalities, if we are to divide by something, we have to stop and take a look. This is a positive number. If it's a positive number, we do not reverse the symbol. Remember, the only time we reverse the symbol is if this was a negative. So the symbol is going to stay the exact same. 2 divided by 2 is 1, so I have 1y is greater than or equal to. That is a negative 3/2 x, and that is a positive 3. So this is the equation that we are actually graphing. We are graphing y is greater than or equal to negative 3/2 x plus 3. So step number 1 was to solve for y. We solved for y. Now step number 2 is to try and graph it. My y-intercept was 3, and I need my slope. My slope's the number in front of x. My slope is down 3 over 2. So y-intercept of 3, slope says go down 3 over 2, down 3 over 2, down 3 over 2, down 3 over 2. Now you cannot connect yet because step 3 is you analyzing your inequality to figure out how to connect. The symbol that we have in our inequality symbol looks like this. There's an equal sign in it. If there's an equal sign, that means we are connecting with a solid line. So now I'm going to use my ruler. Here's me connecting with my solid line, and remembering you need arrows on both ends. So step number 3 was to connect with a solid line. Now, because we're dealing with inequality symbols, step number 4 is to figure out how to shade on your line. Where are all of my answers? So the inequality symbol in the problem we're graphing looks like this. It is greater than. If it is greater than, then you are always going to be shading above the line. Now remembering slope dude, Slope dude always starts on the most left side of your graph. And as slope dude travels along your mountain, where is above slope dude? Above slope dude would always be over here. So it means all of these coordinate points are an answer for us. Anything on this side of the graph paper. So if you were asked to find a solution, pick one point. Any point that's highlighted is going to make a statement true. So anything over here is an answer. And you're done. Let's practice one more graph. So step number 1 is to solve for y. If this is not a y equals equation, I cannot graph this. I have 4x minus 3y is greater than 12. I need to solve for y, so I'm going to subtract 4x from each side. Negative 3y is greater than, that was a negative 4x, and that is a positive 12. I need to get y by itself, so I'm going to divide everything by 3. Now stop. The minute you divided by a negative, you need to reverse your symbol. My symbol no longer points to the right. My symbol now points to the left. We had to reverse the symbol because we divided by a negative number. Now negative 3 divided by negative 3 is 1, so I'm left with just 1y. I flipped my symbol. Now if you need to remember that you flipped your symbol, circle it. Negative 4 divided by negative 3 is a positive 4 over 3. That was our x's. A positive 12 divided by a negative 3 is a negative 4. So we are graphing y is less than 4/3 x minus 4. So this is the equation we're now graphing. Step number 2 is to graph it. So I need to figure out what is my y-intercept and what is my slope. The y-intercept is the lonely number without any letter. My y-intercept is negative 4. My slope is the number stuck to x. My slope is 4/3. So negative 4, I went up 4, 1, 2, 3, 4, over 3. Up 4, over 3. Up 4, over 3. I ran out of graph paper. So as soon as I graphed it, I now need to figure out how to connect it. Looking at the symbol, this is the symbol that I have. If there is no equal sign in the symbol, that means your line is not equal to the answer, which means your line needs to be dashed. So when I am connecting these, I need a dashed line. So here's my dashed line, because the line itself is not an answer. I can get as close to, but the line itself is not an answer. And now I need to figure out how to shade, because I need to know where are my answers. The symbol that you have tells you where to shade. This is less than. Less than always means that you shade below. So if slope dude is on the furthest left and he's traveling along our mountain, where is always below slope dude? Below slope dude would have always been this direction. So anything on this side would have been an answer. And you're done. Now what if you were asked to go backwards? This time you were actually given a graph and you're asked to come up with the equation. Well, we know that we need y with some inequality symbol, mx plus b, slope-intercept form. So if we need a slope and an intercept, let's go ahead and find our y-intercept. That's where you cross the y-axis. I see that it crosses the y-axis right here, and this is the number 2. So I know my y-intercept is 2. Well, now I need to go ahead and I need to find my slope. So if that is one coordinate point, I need to find another exact coordinate point. There's my other exact coordinate point. So as slope dude is traveling down my mountain, how did slope dude get from point A to point B? He went down 1 over 3. So my slope is down 1 over 3. Well, now I need to figure out how is this connected. So looking at it, this is a dashed line, so I have a dashed connect. And where is it shaded? Looking at this, if slope dude is standing right here, the shading was always down here, which was always below. So my shading below. I need one symbol that shows below and dashed. This is the symbol for below, and the fact that there is no equal sign means it was dashed. So if I have to write this in y, some inequality, mx plus b form, I have y, the inequality is below and dashed. I need my slope of negative 1/3. If that is my slope, it needs to be stuck to x. And I'm supposed to add my y-intercept, so I'm adding a positive 2. And this is the inequality for the graph that was graphed for us. Now looking at our second equation, Same thing. We need to somehow write this in y inequality mx plus b form. So I need to find out what my y-intercept is. I need to figure out my slope. I need to look to see how is this actually connected, and I need to look to see how is it actually shaded. So my y-intercept is right here. If that is my y-intercept is a -2. Slope. If that's my first point, where is another exact gorgeous point? I see that it crosses right there. So I would have gone 1, 2, 3, 4, 5, 6. I would have gone up 6, and I would have had to go over 1. So my slope is 6. Looking at it, it is connected with a solid line. And if slope dude was standing right there, where is the shading? The shading is above. So somehow we need to shade above, and it needs to be a solid line. So this is the symbol for above, and if it's going to be solid, it needs an equal sign on it as well. So let's go ahead and fill in the necessary information. I need y, my inequality statement. My m is my slope, which was 6. If that is the slope, it needs to be stuck to x. And I'm supposed to add my y-intercept. My y-intercept is a -2. So here is my inequality statement for the graphed equation. Somehow I need to turn this into a y inequality mx plus b statement. So if I'm looking at this, and this is a curse line. If this is a curse line, you remember from slope dude went undefined all the way down that line as he fell. So it actually can't be put into that form because it's the curse line. If you remember, the curse line was x with some kind of inequality statement, and then you need the number where it crosses the x-axis. So this would have been our curse line. So looking at it, where does it cross the x-axis? It crosses right here. So our x-intercept, because that's where it crosses the x-axis, is at -2. How is this connected? Because that would tell us our inequality symbol. It's connected with a solid line. And if you're looking at the shading, well, slope dude, I don't know where slope dude could be on this because he was cursing all the way down. So I notice my shading is everything that is actually to the right. Now remembering the one trick you learned in chapter 2, if you're shading everything to the right, your arrow pointed to the right. And if it's solid, it's solid. So this is the symbol for this. So I have x is greater than or equal to, what number did my line cross through? It crossed through at -2. Now, remembering the whole right business, that's only for curse lines. Do not do that for any other line. It's only for the curse line. So our last problem of the day. This is not a curse line. So I know that is going to be in slope-intercept form, except for I need an inequality statement. So that means I need to find my y-intercept. And then I can go ahead and find my slope. Then I can look to see how it is actually connected. And then I could take a look to see how is it shaded. So my y-intercept crosses right here, and that happens to cross at 0. So my y-intercept is the number 0. My slope, if that's a pretty point, I need another pretty point. It looks like it crosses right there. So I went down 1 over 1 to get from one point to the next. So down 1 over 1. Well, that simplifies to the number -1. I see that it is connected with a dashed line. And where is it shaded? Well, if slope dude is standing right there, all of this is below his feet. So my shading needs to be below. If it's going to be shaded below, here's my below symbol. And if it's not going to be connected, if it's dashed, that means there's no solid line. So this is the symbol I need. So y is less than, I need my slope, which is a -1. If that is my slope, it's stuck to x. And now I'm supposed to add b, which was 0. Now in theory, this is in proper form. You're okay. Except for I want to simplify it a bit. So y is less than, instead of writing -1x, that's the same as -x. And instead of writing add 0, well, anything added to 0 is that anything. So it actually simplifies all the way down to this. And you're done.
What did we learn today? I can graph and solve linear inequalities in two variables. And I look forward to seeing you tomorrow in class.